Hello. Today I'm going to be doing episode number 4 of the ship designer tutorials. And in this tutorial I would like to address how to do the thrusters of your ship. How do you get your ship to fly as you intended to do so? I'm going to be doing this video in 2 parts. First, I'll be explaining how it works, and secondly, I will then be showing you how to fix common issues and all of the checklists you can follow to fix a solid 95 or even 99% of your problems. Without further ado, let's get going. This is my test bench ship, and we're going to be using it to try and understand in the most simplest of ways what your thrusters need in order to make your ship fly straight. So there's quite a few components. As you can see, all of the ship was meant to be as simple as possible. You can see here generators, batteries, blue cables, yellow pipes, the seat, the levers, the flight controller, the flight computer, the propellant, a whole lot of beams, bolts, hard points, and the thrusters themselves. We're going to be taking everything apart because all of them are required to get your ship flying. It all starts with you, the player. You are going to be pressing keys on your keyboard. Only if you are seated in a pilot chair will those key presses be given to the ship, and only within a 3-meter radius around your pilot chair. On their own though, those key presses are not worth much, and each player may want his own configuration. Thus, it is the V menu that allows those key presses to be meaningful to the ship, as each key press then gets assigned to a button or a lever. So the only ones that are able to hear those key presses of yours are the buttons and the levers. Those are the ones that are going to be doing the YOLOL signals. So signals are YOLOL. And for YOLOL, these signals would be like someone shouting a very specific name. Let's say if say forward, for example, because I want my ship to go forward. And other parts of the ship are going to be listening to that F2 forward, but only F2 forward. These signals can do much more than just be used for the direction of your ships, and I did a whole tutorial on that matter. It's a little bit outside of the scope of this video, but just know that you can use the signals for many things. Now, the one listening to those YOLOL signals, F2 forward, F2 pitch, F2 roll, there's quite a few more, but the one listening to those by default is the flight controller. The flight controller is going to be doing 2 things. First, he's going to determine the direction of your ship. It's indicated by the arrow that's on top of it, and he's going to be sending that signal to the flight computer. So the flight controller makes the flight computer aware of the desires of direction of the player. The flight computer, who can control up to 50 groups of thrusters that are part of the ship, will then understand what thrusters need to be used at what proportion to get the ship in a given direction at a given speed. To be recognized as part of the ship, a thruster needs to be bolted to beams that are also bolted to the hard point that is feeding the thruster in electricity and propellant. Now, there was a whole lot of quotation marks and asterisks and small writing in what I just said. Don't worry, I'll be addressing all of those points one by one because there's a lot to unpack. Now, even though the information is sent to the thrusters, they still need electricity and propellant in sufficient quantities in order to work as intended. Where it gets quite complicated, especially for new players, is that all of these individually can all cause failures in having the thrusters turn on, or even having the ship fly straight or just fly at a reasonable speed. I'll use a cake as an example and say that all of these elements were the ingredients. I'm now going to show you how they need to work together to have the ship work as intended. I'm going to direct you to the top right of your editor to enable the center of mass and the center of thrust. Unlike other games, such as Space Engineers, The position of your thrusters relative to your mouse is of great importance to Starbase. The purple square is straightforward. It is the center of mass of your ship. The blue square represents the center of thrust of your ship, and by default it is the center of thrust of all of the thrusters that your ship has. By selecting thrusters, you will be moving that blue square as it's going to move to represent all of the selected thrusters. The blue line is simply the axis of thrust of your ship. It is very simply a guide to help you properly align the center of mass with the center of thrust. The reason why this information is so important is because it is going to be very relevant to how the flight computer is going to attempt to use your thrusters to get your ship to fly as you, the player, intended to do so, which means flying straight when you just want to go forward and turn only when you choose to do so. By default, your flight computer will absolutely want to keep your center of mass in the exact same spot whenever you are turning, be it yaw, pitch or roll. So that weird contraption you see me show right now is very simply beams to show the position of your center of mass. Now, as you can see, when the ship rotates, that center of mass remains in the exact same place. So in this ship, the center of mass and the center of thrust are almost one on top of the other. So what I'm going to do is that I'm going to make a counterweight at the front of the ship. I'm going to use lithium plates to make it nice and heavy and push that center of mass forward. I'm also going to move the indicators, the beams at the front, and show you that with the new center of mass, the ship still wants to turn specifically on that axis. And as you can see, it is using all of the thrusters it has access to. But this is a test bench, and this test bench happens to have an equal amount of thrusters facing all directions, presenting a very ideal situation for the flight computer. It also happens to not be representative of most ships you will see. So let me tinker with these thrusters a little bit and make something a little bit more representative of ships that you're going to be able to either do or find, and show you what effects it is having on the flight computer. Now, as you can see, the ship is still maintaining its axis of rotation, which is the center of gravity of the ship, but it is now doing so at a much slower rate. So this is very representative of how the flight computer is attempting to use the thrusters to achieve this rotation. So I'm going to pause the video just here, and I'm going to be using schematics to show in more in detail what exactly is going on. So the center of gravity is just here, and the thrusters being used are maneuver thrusters and box thrusters. Maneuvering thrusters and box thrusters do not have the same amount of thrust at all. The force of the thrusters, which I'm representing here with these red arrows, are applied relative to the center of mass of your ship. So I'm going to be drawing a few more lines just to represent those effects. So these lines are placed 90 degrees compared to the axis of push of those thrusters to represent the effect on the center of mass. So I can move the arrows a little bit just to make it a little bit more obvious as to what exactly these thrusters are doing. Now, as I stated previously, the main flight computer wants to keep that center of mass where it is at all times, using all of the thrusters made available to it. And although that box thruster has got so much more thrust available to it than the maneuver thruster, it cannot be used fully, because if it did, it would shift that center of gravity completely off axis. Thus, the thrust that it can give is greatly reduced to match that of the maneuver thruster, which has considerably less. To demonstrate this, I redid the test bench, and this time I only have maneuver thrusters to have thrust of equivalent value. And even though I lost quite a lot of forward thrust, my ship just won't fly as fast, the rotation speed is still exactly the same as seen here. Understanding the way Starbase ships want to work is especially important whenever you want to build one, but it becomes even more relevant whenever you want to do a role-playing ship. I have seen quite a few new players join Starbase with the expectation that they'd be able to rebuild their absolute favorite Star Wars, Star Trek, Warhammer ships and have them fly just as they would in games such as Space Engineers. And although Space Engineers doesn't really fuss about it all that much, in Starbase, not understanding how these thrusters work results in a ship that just absolutely does not want to fly fast, or worse, doesn't want to fly straight. Doing role-playing ships is very much possible, but only as long as you understand how this center of mass and center of mass stuff works. This said, Starbase allows you to be very creative with the way you use your thrusters. This ship is the Gladiator. It's a heavy fighter of mine that I've designed, and the point to which I'd like to get your attention to is that all of the thrusters of this ship, including rotation, yaw, pitch, all of them are at the back of the ship. Not a single one is close to the center of mass. And although the ship does look like it's derping around it a little bit in the beginning, it does eventually stabilize really close to the center of mass axis that I've been talking about. But there's a little bit more than meets the eye here, because this ship doesn't have one flight computer, it has two. As a matter of fact, the upper limit of flight computers that you may have in a ship at any given time is 5. Since this is quite an advanced topic, I'm going to show you how to do it later in the video. For now, I'm just going to use these two flight computers to illustrate a little bit more as to how flight computers are working in the game. So I already showed you the first mode, where the flight computer absolutely adamantly wants to keep the center of mass in the exact same place. But there's a second mode, where it kind of acts like a rocket, where it doesn't mind too much the center of mass moving. The Gladiator has got two groups of thrusters. It's got the normal thrusters, which kinda are all around the ship, and then you've got the big groups of thrusters right at the back that kinda act like a rocket. So here are the two flight computers and the two flight controllers. They are both linked to one another thanks to their name. You have just seen me add an underscore to the name. That was to disable it. If we go back to the schematics, I show you all of the elements that communicate to one another. I've just nipped the part where the flight computer is listening to the flight controller. Remember, it's one of those events. One is shouting, I am talking to main flight computer, and the other one is now listening to, hey, I am listening to main flight computer, but with an underscore. Hence, they're no longer able to communicate with one another. As I said, it's a bit of a complicated topic. I'll be going more in depth on it later in the video, where I'll also show you why you'd even want 2, 3, 4, 5 even in the first place. But as of now, just think of these as nifty on and off switches that I'm using just for the purpose of showing you the different neutral steering and rocket modes, as I'm going to be calling them. So here is the Gladiator doing the neutral steering. Some of the thrusters at the back were disabled, and as you can see, this time the stick representing the center of mass is not budging. So the new mode, which I'm calling the rocket mode, it's not an official name, I'm going to re-enable the previous flight computer and disable the other one. As I said, it's the same nipping I've just talked about, and this time only some of the back thrusters are going to work. Now let me show you what it looks like on the test bench that I've been using for most of this video. And same thing, I'll be removing all of the existing thrusters except for the back ones. Also this time, instead of just letting it fly away, I'm just going to hop in the ship and use it. And as you can see, the ship handles absolutely fine. I can yaw, I can pitch, I can go forward, but I cannot roll, I cannot reverse, as there are no thrusters allowing me to do so. I also cannot strafe. So I showed you the neutral steering, I showed you the rocket mode, but there's an in-between where the main flight computer is just not going to work. The broken mode only really is a broken neutral steering mode, as the flight computer, given enough thrusters, is systematically going to be choosing to try and attempt to keep that center of mass in the exact same spot. And here, in this test flight, you can see that the ship can advance and roll on itself no problem, but the very moment I attempt to yaw or to pitch, the ship does so slowly. To further illustrate what I'm talking about, let me put that center of mass indicator back on the test bench to show you what is going on. And here you can see the main flight computer doing its best. The center of mass kinda stays in the right place, but it's really slow. This is the broken mode. It's attempting to do neutral steering, and it's just not succeeding at it. Keep in mind though, this ship is turning. Some of them in the broken mode will adamantly refuse to do so. Now, on the next step, I'm going to build a very simple ship in order to show you the application of the schematics and understanding what can and cannot be done with the main flight computers, controllers, levers, so on and so forth. I'm going to start here with the generators, and if you haven't done so already, I highly recommend that you see my tutorial that I've already done on the topic. It's going to explain you all you need to know about generators. For the propellant, I'm very simply going to use a small propellant tank, as this is only really meant to be a demonstration ship. But if you want to design a ship with a specific range in mind, you can use my online calculator, which I've done specifically for those kind of purposes. This done, I'm going to be using some ducts on the side for the electricity, propellant and data. Next, the brains of the ship, the flight computer, the flight controller, but I'll also be adding a transponder. As you've probably already noticed, I'm going through the checklist of all of the items necessary for a ship to work. Moving on, I'm going to be placing the pilot chair, as it would be very difficult to use the ship otherwise, and I'm going to be bolting everything. Here, I'm using the auto bolt tool. I'm just going to caution you against using it, as it's a very double-edged sword. For small ships like this, no problem. On big ships, avoid it like the plague. Going on, I need to cable and pipe the ship. The blue is for electricity and data, and the orange, the pipes, are for propellant, heat, and ammunition, although my ship has no guns. Ducts are very handy, as they do not cost as much in the cables, pipes, and ducts budget, and they transport absolutely everything with no distinction. Next are the levers. I'm going to need them as the pilot chair does not enable you to communicate directly with the flight controller. You need the levers. More specifically, you need one lever per control that the flight controller allows you to have. I'll use this opportunity to say that there's a total of 3 flight controllers, and they are not equal in what they allow you to do. You have the basic flight controller, you have the advanced flight controller, and you have the premium flight controller. The only difference between these 3 flight controllers is the price associated with crafting one of them and the instructions that are available for each one of them. The basic one does up to FC rotational roll, the advanced one will allow you to strafe, and the premium one will allow you to combine multiple movements at once. The players do tend to prefer the advanced one, but you can use any that suits you. So I've got all of my levers, and just for the sake of making it fast and simple, I'm going into the flight controller and I'm copying the names of the instructions, FC forward, FC backward, and whatnot. Do keep in mind that forward and backward are 2 separate instructions, whereas strafing left and right is one instruction. So you need a lever that goes from 0 to 100 for the forward and the backward, and you want a lever that goes from minus 100 to plus 100 on the other instructions. Your ship can attempt to go forward and backwards simultaneously, although I think you can know that the end result is not going to be very interesting. Before I go any further with the design of this ship, I'm just going to illustrate something quite important with this new test bench you are seeing right now. On the condition that the buttons and levers are within a 3-meter radius of the center of your chair, all buttons can be pressed through the keybind, the V menu I've been talking about. The presence or the absence of obstacles in between you and the buttons is irrelevant. You can have a wall and your buttons on the other side, it will still work. But if you're over the 3-meter range, your inputs will no longer be held by the buttons or the levers. Back to the ship design, I'm bolting and cabling the levers to allow the pilot to communicate with the ship the instructions of where he wants to go. I'm also just going to add a few batteries. And now I'm going to be addressing the thrusters, arguably the most important part of a ship. For the sake of simplicity, I'm going to be building 2 box thrusters which I'm then going to mirror on either side. So I need beams, I need hardpoints, I need the thruster components, and then I need to put them onto the ship. Takes me a little bit of time to snap everything into place, weld everything, make sure everything is properly bolted. And now, after all of this time explaining you how ships work, here comes the very important question. What makes a ship in Starbase? The question is funny. I mean, I've just spent more than 20 minutes explaining you how to get a ship to work, and now I'm asking you what a ship is in the first place. The question, though, is really important, because this is how the game determines whenever your ship is taking in damage, because you've rammed something, because someone's shooting at you, it allows the game to know what your ship is. Is it the pieces that are flying off in the distance? Or is it what you are sitting on? And even though for us humans, distinguishing the ship from debris is really simple, programmatically, from the game's point of view, it's not that easy. And the key to the answer is that a ship is a ship as long as the thrusters are bolted to the beams and the hardpoints are also bolted to the beams. It has nothing to do with your transponder, the pilot, or any other accessories that you may put on the ship, as I've seen quite a few players speculate. I'll be even more precise and say that in order for a ship to be recognized as such, you need a minimum of 3 beams that are connected to one another. Having 3 beams not connected does not count. So the previous schematic I showed you would be more accurate if presented this way. And if I go back to the ship, you will see that the entire ship is not recognized as one because the hardpoints were not bolted to the beams. This is important because the flight computer will only use a thruster that is recognized as being part of a ship, and these do not fit that category. To further illustrate this, I'm just going to finish the cabling and the piping of the ship, but I'm not yet going to bolt the hardpoints. I just want to show you in action what not having the hardpoints bolted means. So everything else, the levers, the computers, controller, the propellant, everything gets piped and cabled, but I don't bolt the hardpoints. So here I'm trying to press all of my keys on my keyboard, and well, obviously you can't see it, but I then go under the ship and I try to move those levers by hand, and once again nothing happens. This time I bolt all of the hardpoints it should be. As you can see, I check for the durability is being displayed, and although the ship only has enough thrusters to do a rocket mode, it has enough thrusters to go, but it doesn't move at all. Here, this mistake conveniently leads me to my next point, which is the thruster names. So, as I've stated, the ship really works with events, aka someone shouting, and those events are being listened to, which in turn gets the flight computer, which is shouting those events, to be listened to by the thrusters. And the events that it is shouting about is thruster power level. Okay, I'll pause the ship design just here, and I'll open up another test bench to show you a little bit more about thruster names. By default, all new thrusters are called thruster state, but the flight computer wants thrusters that are called thruster power level followed by a number. So as it is, there's no communication. Obviously, renaming all of the thrusters by hand would be horribly tedious, and Starbase gives us a very convenient tool to rename all of the thrusters for us. Now, the expression too good to be true is very much something to keep in mind here. You first saw me click on automatic, that's what names all of the thrusters for me, and then I clicked on manual. That is because if I didn't, it would continue to auto-name all of the thrusters for me. So I make sure to only enable automatic when I want the thrusters to be changed. Now what about those limitations to trap that double-edged sword I was warning you about? Well, the first problem is that the tool is dumb as a brick. It's not intended to be smart and never was designed that way. It will name all of the thrusters, no exceptions. And if you go over 50 different thrusters, you will end up with over 50 different thruster groups, which in turn means that your thrusters will not be recognized by your flight computer, which can only manage 50 at a time. In this case, those thrusters are disconnected from the ship, then doesn't really matter, and surprisingly, all of the thrusters on the main ship appear to have the correct names. But don't always count on it working, because I assure you that is a problem that really bites. Moving on, there is a situation where the thruster naming tool is incredibly convenient and reasonably safe to use, and that's going to be with triangle thrusters. The triangle thrusters have got grey little connectors on 3 of their sides, really in the middle. If another triangle thruster has its own connectors connected to the other connectors of the other thrusters, then they will be considered as one big thruster by the flight computer. And where it's really nice and convenient is that the thruster naming tool is very much aware of that. So when I use the thruster naming tool, all of those thrusters are considered one and named correctly. It's really convenient. There is, however, yet another very important pitfall to be aware of, and that is that those connections work regardless of the orientation of your triangle thruster. So if you start putting triangle thrusters side by side with different orientations, they will be considered as one and act as such. And if you change those triangle thruster names by hand in order to have your different groups pointing in different directions, they are still going to act as one, but the flight computer is not going to be aware of it. And the ship is going to fly completely off course because the flight computer is no longer going to be using your thrusters correctly. Let's get back to the ship design, where I'm going to be showing you a little bit of debugging. When building your ship, it doesn't matter how small, it doesn't matter how big, test it regularly. There's going to be plenty of problems to find, and you do not want to find them all at once, as they compound, and the more you have, the harder it is to solve. Your new favorite tool is going to be the U tool. It is the tool that is going to allow you to know what is going on inside of your ship. The thrusters that I had just checked had data, they had electricity, but a double check shows me that they had no propellant going to them. So the flight computer was giving them instructions, but the thrusters were not able to comply. Hence the ship just spinning on its own completely mindlessly. I also had the missing instruction roll on my ship, not that it could use it as it's on rocket mode, and also the ship had a cruise enabled forcefully by default. This meant that because the lever had no centering speed, any input I'd give it would be kept, so the ship would just keep going, even though I was no longer doing anything on my keyboard. And there you have it, a very, very simple working ship. Now obviously we're not going to stay there, I mean the ship is way too simple, it doesn't even roll. So let me just correct that, and I'll be adding a few maneuver thrusters in order to have at least a very simple roll, strafe, and reverse. I'm going to choose the straightforward and easy lazy method, which is to prepare a module that I'm then conveniently going to be able to copy paste 4 times. So in this module, I make sure that everything is cabled, piped, bolted to both the hard points and the beam, and only then do I want to copy paste it. I'm not going to be doing the names yet, so I'm just going to make sure that everything is placed before doing so. Because the module allowed it, I'm now able to cable and pipe the maneuver thrusters very easily to the body of the ship. And for the final touch, I can put 2 reverse thrusters, maneuver thrusters, on the ship. Once again, I bolt, I cable, I pipe, and I make sure everything is connected as intended. Before going any further, I check for the durability of the ship. Here, it is displayed as red. This means that the ship, if going at nominal speed, aka 100% of its thrust, is going to have stuff detaching. So by default, in the ship designer, the safe mode is enabled. I'm not aware of it being possible to disable it. This means that you get a warning in the chat saying that your ship has got a durability error, and in turn, the speed of your ship gets greatly limited and you can hear these grinding sounds. In this case, it's the beams, so the solution is literally as simple as adding a little bit more beams. But had it been something else, I probably would have had to use bolts to bolt whatever was causing trouble to a beam. And once everything is welded, the ship has got no durability issues and it's good to go. I mentioned quite a few things about thruster groups, but all you've seen is mostly, except with the triangles, single thrusters. As far as the flight computer is concerned, if multiple thrusters have got the same name, they are one thruster. The main flight computer no longer differentiates them at all. It is that simple. So as you see on screen, when those thrusters have got the same name, as far as the main flight computer is concerned, those are just beefier box thrusters. Simple as that. The one thruster I didn't put on this ship because of its size is the plasma thruster. It is by far the biggest of the thrusters, and unlike the others, it is modular, as it is made of a body and rings, and you can add as many rings as you want as long as it fits in the ship designer. There are 2 different kinds of plasma rings, the ones with the structures and the ones without. The structures are the pointy bits that you see coming out of the rings. They have the same amount of thrust and have the same requirements in electricity and propellant. The only difference is that the ones with structs are going to be slightly more expensive both on the voxel volume and on the construction costs. They are also a little bit more convenient to bolt to your ship. Those are the only differences. A quirk of plasma thrusters in general is that the body, the big part of the plasma thruster, outputs a total of 5 million of thrust. But it also costs you a whopping 100 million in the voxel volume. At contrario, the rings will cost you much less voxel volume and will output 7 million of thrust each. Thus, there is a strong incentive to make them as long as possible. Another weird quirk the plasma thrusters have is that you can turn them on and off. That would be the is active value that needs to be turned to 1. From then on, the plasma will turn on and continuously use electricity. The charge level is then going to go from 0 all the way up to 1 over the course of 60 seconds. It will then require an additional 60 seconds to warm up, as seen in the description, although that is not going to be displayed into the data fields. Additionally, remember to put a hard point, to bolt it correctly, pipe and cable it, and voila, it's going to be a normal thruster as far as the flight computer is concerned. So, at the start of the video, I announced that I would be both showing you how to build a ship, but also how to fix a ship. It's time that I show you how to fix the ship. Before showing you my solution, the great reveal, I first need to remind you that ships are incredibly complicated in Starbase, and each and every single component can be the source of not one, but multiple sources of failure. Here's what I devised to be able to help you in this video, but also in the future. Now, before you shut the video, start screaming in pure horror, which to be fair would be completely understandable, give me at least a minute or two to present to you what it is, show you how it works, and defend my point. What you're looking at is a checklist that answers almost all of the problems I know that can happen on ship. You start with one of the 3 orange boxes, which are the entry points, and then you move to the white boxes, which will systematically ask you a yes or a no question. The yes is systematically on the left and the no is systematically on the right. Moving along on the graph by answering the questions should allow you to end on a green box, which should then solve your issue, or on a blue box, in which case either the graph is incomplete or was not used correctly. Obviously, I don't encourage you to look at the graph through the YouTube video. I'll be providing you a link to get to the latest version. Speaking of latest version, this is a graph that is destined to be able to evolve. As new issues are found, as new odd situations are found also, they will be added to the graph. It's a community effort which I've been piloting, and hopefully it's going to get big enough to the point where it can truly solve 100% of the issues reliably. Obviously, I can't reasonably expect you to just take this graph as is and be able to use it out of the blue. That just doesn't work like that. So I'm going to be using my ship that I've just designed in this video, and I'll be using it as a test bench to show you how it works. But first, I need to prepare it. Thank you for your patience. Now that the ship has been prepared, I can show you how to use the graph to fix the ship. The very first thing I'm going to want to do is hop onto the pilot seat and try to use it. Immediately I notice that the ship is not responsive at all, and even moving the levers by hand yields no result. So let's start with the graph and go step by step as to how to address the problems, because there's multiple and the graph is done to allow you to solve them one at a time. As I said previously, we start the graph with one of the 3 orange boxes. We have the complete ship checklist, the thruster not working, and ship issue checklist. Since I do not know yet where the problem lies, I'm going to start with the complete ship checklist. Now all I need to do is follow the arrows, and the very first question is the ship flying or moving? The answer here is a very simple no, and since all of the yes answers are on the left and the no answers are on the right, I shift to the right. The next question is, are some thrusters on? Since the ship was absolutely not moving at all, the answer is no. Are you within 300 centimeters of the levers? The answer here is yes. Are the levers reacting to your keyboard inputs? In this case, since my levers are under my seat, I'll just have to tweak a little bit. I'll add a second seat because I want to visually see if my levers are moving or not. The second seat is temporary. Once the test is done, I can remove it. And as you can see, the levers are moving just fine, which answers the question on the graph. I can now keep going down the graph to try and find the issue and move to the next question. Is the flight controller reacting to the levers? So as it's written just on the right, I need to use my U tool to check if the lever's doing anything has the flight controller reacting. So here I want to use the U tool on the flight controller, sit on the seat and move the levers. The intended outcome is that the values on the flight controller should be changing. Since this is a very clear no answer to is the flight controller reacting to the levers, I'm going to be going down that checklist. Next question. Are the name of the levers the same as the flight controller? So here I'm going to be clicking on the flight controller and I'm going to be checking the names of the levers to ensure that it is a 1-1 match. It's the famous events, the shouting and the listening to I kept referring to. In this case, I'm pleased with what I see. The names are a match, so I'll keep going in the checklist. The next question asks, is there a cable that is linking the levers to the flight controller? To make it nice and easy to check, I can use the different layers and hide anything but the devices where both the flight controller and levers are and the cables. And as you can see, there is a connection here that is indeed missing. So all I have to do is add the missing cable. Back on the graph, you will see a very simple explanation that you need a cable, the blue connection between the levers and the flight controller. The green boxes are the solutions to existing problems. I now need to test the ship again just to ensure that it is working as intended. So here I am trying to go straight and the ship is doing anything but going straight. But it's progress. The ship didn't move and now it does. So when it comes to the graph, I now need to go all the way back up to the starter points and re-answer the very first question. Is your ship moving? So this is a very important aspect of this flowchart, this graph, this checklist, doesn't really matter how you call it, is that it solves one problem at a time. I've addressed the problem with my flight controller, but that problem was hiding other problems that did not have a chance to manifest because the ship couldn't move. Now that the ship can move, new problems are arising. Hence, I go back to the beginning of the checklist and I start again. Is the ship moving? This time, the answer is yes. Does the ship stop or go off course after a few seconds? Well, in this case, it goes off course immediately, so the answer is no. Next is, are all thrusters turning on at least once when doing all possible maneuvers? So, as stated on this side, you may require to place an extra cockpit, so I'm going to show you right now what this entails to be able to answer this question. To make it nice and easy, I'm going to take the bottom cockpit that I placed previously but forgot to remove and put it at the back in a place that will allow me to see all of the thrusters. I'm also going to be placing a second set of levers as the first ones are going to be out of reach in a way that allows me to see them from my cockpit seat. Now, some of you may have already noticed a problem, which is a missing piece of propellant pipe. I'm, however, for the sake of showing you how the graph works, going to pretend like I'm not seeing it at all. If, however, while following the graph you see something this obvious, obviously please fix it. But, as I said, for the sake of following the graph, I'm going to show you how to follow the steps one by one. And sometimes those missing propellant pipes are not that obvious. Here I can see it is painfully obvious that two of the thrusters are not turning on. So I can go back to the graph and continue following all of the steps. Once again, are all the thrusters turning on at least once when doing all possible maneuvers? The answer is no. Going on. Do you have more than 50 thruster groups? So here I'm trying to determine if maybe your thrusters are not turning on because you have too many groups. To check this, I very simply go back into the ship designer and I click on the thrusters to see what thruster value number is there. If I see any with a value over 50, then I know that there are too many thrusters. Having checked, I can confidently answer no to that question. The follow-up question is to know if the thrusters have got big numerical values in the thruster state device field. So I need to press F5, I need the ship running, and I'm going to be running the utool to check for the ID, as seen here. This ID is the proof that the flight computer is correctly communicating with the thruster. You will also see that value move whenever the thruster is supposed to output some thrust. So, do the thrusters have big numerical values in the thruster state device field? Yes, they do. So, are your thrusters responding to a user input? So I have to hop back into the F5, and here what I want to test is if I manually write a value of 10,000 where the ID is, does the thruster turn on? In this case, the answer is no, but for a thruster that works as intended, this is the expected outcome. It pushes the ship. So, are your thrusters responding to a user input? The answer is no. Is there a blue cable linking your generators to your thrusters? So this is also going to include the heatsinks and the ducts. I'll probably add that in version 1.2 just to make the question more precise. Once again, back to the ship designer where I check the output of the generator socket board. And although it's a little bit of a detour, there is indeed a direct connection from the generators to the thrusters themselves. I can move on in the flowchart and ask, do your generators generate electricity? Although I was able to move my ship around, it's tempting to immediately answer yes, but I'm still going to give it a quick check with the utool to ensure that the ship wasn't moving thanks to the batteries alone. Satisfied with this answer, I move on to the next question. Is there propellant on your ship? The answer is yes. And next, the chart asks you, is there a pipe linking your thrusters to your propellant tank? So as written just on the side, you can have like heat sinks and ducts transferring the propellant, but you still need to ensure a proper connection. Since the answer is no, I end up on the solution of the thrusters need propellant to be able to work. If I hop back on my chair again and use the ship, you will see that it does work. There still are errors though. So I'm not going to address those errors in this video anymore, as I think I've made the point abundantly clear as to how to use the workflow and how to get optimal results out of it. The workflow is really big and it is community driven. At the time of recording this video, there's already been quite a few suggestions and update on the graph, so it's already changed. If ever you yourself experiment any issues, dissatisfactions, or have any suggestions or feedback to have on the workflow, by all means, please do write about it in the Discord. The link is going to be in the description. The better this graph is, the better it is going to be able to allow everyone to solve issues. And thus, I have finished presenting my graph and how to use it. Hopefully this will be useful to you in allowing you to fix problems that would have otherwise cost you quite a lot of time. And I'll be moving on to how to use multiple flight computers on the same ship and why you would want to do that in the first place. The ship you're looking at right now is the Apex. It's a 30 laser combat ship that is quite meta, that I've been using very extensively both on the live and on the STU for a lot of combat. And like most of the meta ships, it has all of its thrusters completely at the back in a bid to protect them from enemy fire. But this causes one problem. The ship will immediately go into neutral steering mode, giving the possibility. And it is going to be painfully slow to have the ship turn, which is completely unacceptable in combat. So to be able to have both the benefits of the rocket mode and none of the inconvenience, the thrusters are separated. So you have one flight computer controlling the rotational thrusters, and another flight computer controlling the propulsion thrusters. So, if I go back to the previous graph that I've shown you quite a lot already, This is what a ship looks like with one flight computer, but this is what it looks like with multiple flight computers. So the premises are still the same. You still have your player, you still have your inputs, you still have your levers, your button. But the first difference is going to be with the flight controllers. There's going to be two of them. In this case, the first one is only going to be listening to going forward, pitch, and yaw, whereas the second one will only listen to roll. Each flight controller is going to be communicating to its own flight computer. They're not going to mix. And in a similar fashion, each flight computer is going to be communicating to its own set of thrusters. And here lies one of the most important aspects. The flight computers are not aware of one another, are not controlling the same thrusters, and are not allowed to control the same thrusters. As far as the flight computers are concerned, each of them individually are controlling one chip. So to avoid this crisscrossing of information, I've added 321 in the flight controllers to prevent them from listening, as that event if the forward 321 just does not exist. And the thrusters, the second group, the maneuvering ones, all have names that go from T1, T2 and so on till T8. This prevents anything from having aware of one another if they shouldn't. This is but one of many possible usages of multiple flight computers. You can also have a flight controller that obeys exactly the same set of instructions as the other one, but controlling maneuver thrusters only. This in turn could potentially allow you to have a stealth mode. As an example, here's yet another of my fighters, an ongoing project that's going to have maneuver thrusters for such a purpose, being able to move stealthily. Turning off a flight controller is done through the MFC multiplier. That is usually where you'll see players apply a turtle mode, but if you put the value down to 0 through a button for example, this in turn will allow you to disable the thrusters that are associated with the flight controller. And there you have it. Thank you a lot for going all the way through with this very long video of mine. It was very roughly 50 to 60 hours of work, and I truly do hope to be able to help a few players with all of this huge amount of information. All of the links are going to be in the description of this video, and I'll be more than happy to answer any questions should you have any there. Bye bye, thanks again.